when you're given this kind of problem. Okay, first step, what's the instructions? Solve it. If it just said solve, I would try to factor it. But the damn thing says by completing the square.
So each step.
Yep. Hugely important. You guys remember that shirt I wear says show your work? I had somebody turn in homework in one of my other classes. Going to have a discussion because it was just answers. And there were a few that had a lot of work behind it. I'm like, no. So you got to show me your work. First step is divide by 6. Everybody's going to love this because then the middle term becomes 7 over 6, right? That one you cut in half and then you square it. Are you guys with me? Are you guys with me? So there's two things going on. You have to understand how to complete the square. Period. Right? Is that cool? You just have to know how to do it. Whatever the shit is there, whatever's there, doesn't matter. You still apply exactly the same steps. So is everybody cool with the fact that the middle term will now be 7 over 6. I'm going to go ahead and add the 20. Make some room, right?
Yeah.
How do I cut 7 over 6 in half? That's the first step, correct? Whatever the middle dude is, cut him in half.
You multiply the denominator by 2.
Yeah, you take 1/2 of 7 over 6. So whenever I have a fraction in the middle, dividing by 2 is the same thing as multiplying by half. In fact, division does not exist. There's just multiplying by the reciprocal. So division by 2 means multiply by a half. Exactly. Okay. So you get 7/12. What would the second step be? Take whatever you get and square it. Yeah. So I'll do that much for you. The numbers, are they pretty? I really want you to understand how we really don't care. We don't care. You're like, you might not care, math boy. No, we all don't care because I just have to put the shit in the right place. I don't have to actually do much with it yet. So that's as much as I'm going to do. You guys keep going. Now, if you wanted to, you could kind of factor on the side and know what the answer is supposed to be. Because I think this is factorable. Yes.
When you move the 20 over, it's just 20. There's no 16 more.
Oh, I'm sorry. Yeah, thank you. I had two things in my head at once. Sorry. Which makes it even more. Yay. You guys okay? No?
Get in there.
So again, whatever's in the middle, as long as the first number's a 1, whatever is in the middle, you cut it in half. Right? And then whatever the shit you get from doing that, you square it. It's at that point, it's very, you're not even having to think much about it. You just do those things. It's when you put it back in and you have to combine like terms, you need LCD. That's the worst part of this, is just getting an LCD. Yeah.
How did you get 7 and 12?
What's 1/2, right? Because you got to take the middle term and cut it in half, correct? What's 1/2 times 7/6? 7/12, correct? Yes? Sorry, you look like you're in pain. So if I have 3/4 times 7/5. How do I do that? Multiply straight across, right? Is there anything you can reduce? Nope. So 3 times 7 is 21. 4 times 5 is 20.
Well, why did you multiply it by 1?
Oh, okay. Okay. If I have this problem, what would be your first step? Take the middle coefficient and do what to it? What's the first step in completing a square? Divide by 2. So then I would just do -9 over 2, correct? But what is the same thing as division by 2? Isn't multiplication by a half the same thing? So if the middle term is already a fraction, write the 2 as a fraction. They go together better that way. If I write this, 7/6 divided by 2, does that look good.
Okay.
That looks bad, right?
And
That's fracception is what I call it. Fraction within a fraction. You gotta spin your little. Sorry, go ahead.
does the third term always go after like the 12/6? So like you got
12/6.
yeah.
Where's that?
Down there.
Where? Sorry?
Yeah.
This is 20/6,
Oh,
7/6.
20/6.
20/6.
So you always move that to the other. Okay.
Yes, because I need space right here, right, to put the answer to what that's going to be.
Okay.
So you make room, yeah.
So there's no negative anymore.
In this problem, no, because when I add that over, is that all right?
So it always becomes positive? If
No. I mean, so let me see. Of course, every single problem up here.
So if it's positive.
If this was a
it's
plus, I would subtract 5 from both sides. I need to
Oh,
get
okay.
whatever's there out of the way. In this case, it was positive just because I had to add it because it was negative to begin with.
negative. Okay.
I like it. Yes.
So, 3/6
Nope.
how do you, square root both sides?
I don't. Oh, I see. We know how to square root. It is 50 a perfect square? What do I get when I square root it though? Can't I do stuff with it? Okay. I don't need a perfect square to be able to take a square root. We just get what we consider to be kind of an ugly problem, an ugly number, poor little number. Is that all right?
So like, I'm just wondering, like, how do you find the key? Like, you can't like square root both sides.
Couldn't the answer be square root of 11? Okay. You can't square root 11, can you? But that's an answer. Yes? Okay. Yes.
Do you add 49 over 140 each side?
Beautiful. Well, yes. 49 over 144. Yes. Which really kind of sucks because then you got to get an LCD. So this problem is a fraction heavy problem, which is why me being evil and a math boy, I love it. Right? We have got to get over our fear of fractions. You know the processes. You know, well, you should. And if you don't, come see me. It's just something we don't want to do it, do we? I don't want to do it either, to be honest. But I'm always curious what the hell the answer is, and if that's what it takes to get there, I'm going to do it. And you're like, I don't care. Well, too bad. You got to do it. You want a good grade. So there's some motivation. Okay. I would hope somebody out there is like, I want to know what the answer to this damn thing is. Anything else? There's another question I want to do before I forget. Yes?
Can you do another problem?
No. Yes.
Can you do 18 and 35?
Oh, a twofer. On the same section, I guess?
Yeah,
So this guy?
yeah.
What sucks about 18? Yeah, there's a fraction, right? There's several fractions. You guys got to. What kicks ass about equations is for almost anything you say, man, I wish that wasn't there, you could just freaking kill the shit. Because what am I allowed to do to both sides? Almost anything I want to, as long as I do it to both sides, correct? I can't multiply both sides by 0, for example, right? Because then every equation would be 0 equals 0, we'd be living in caves still, blah, blah, blah. Not really, but you get it. So, I mean, how do I kill, for example, the O divided by 3? What would I do? What would I do to kill that? Multiply by 3. How would I kill the divided by x? Multiply by x. Are you guys with me? How do I kill the denominator of something when I'm allowed to? Why am I allowed to do it here? Equation. I've got two sides that'll balance. If I just give you fractions, not an equation, you can't kill the bottoms. You can't do that. You guys with me? Do you guys all agree that if I multiply by 3, I kill the first fraction? No more fraction, yes? If I multiply by x, I kill the second fraction. No more second fraction. So what do I multiply to kill them both at once? 3x. If I multiply by 3x each term, and that's what keeps it legal, yes? You guys with me? This was a nice, no. Do you agree? Do you agree that if I just multiply by 3 every term, Is that all right? Am I allowed to do that? Hell yeah, I can multiply both sides by 3, correct? If I do that, doesn't that make this fraction go away? 3 divided by 3.
Oh, so, yes.
Yes, of course. The 3's on the top, the 3's on the bottom. Of course they cancel, right? But do I kill this fraction?
No.
No. So why don't we multiply by the LCD? Why don't we multiply by 3x?
That would take both the 3 and the x out?
So the 3 goes away, right? You agree?
Uh-huh.
And what's x times x? Because the x is still there, yes?
Yes.
X times x.
X.
Squared.
X.
Here the x dies, yes?
Yes.
9 times 3. 2 times 3x. Does that look
Okay.
way better? Does it still look a little gross?
I kind of get it.
The important thing is, when you're solving equations, almost any time you see fractions, you can kill them if you want to. Most of the time you actually need to, especially when the variable's on the bottom. I can't do shit with that. How do I solve for a variable that's stuck on the bottom? I need to multiply it up. How you guys doing? All right, yes? The 3 died, right? The 3 immediately died. Right? So if they're dying, let them die. There's no revivification spells or anything to do. Yes?
Is there any more steps for that?
Oh, hell yeah. That's a homework problem. I've already done too much. You guys keep
Number
going.
55.
Yeah, we're going to do that one, actually. That's funny. Somebody else had the same question.
uh,
Real quick, what would I do next?
I don't know.
Subtract
I would
six,
divide by
I love you guys. So, when it was, what was the one, right, what did we do next here? What section am I in? I'm still in the completing the square, is that right?
Yeah,
Yes.
Yeah, okay. What did I do next here? I kind of did it kind of all at once, but what would you, where do I need to make room for computing the square to do it?
Divided 20 over 6 to the other side.
Yeah, exactly. I gotta get whatever's here, I gotta get it out the way. So I want my p squared term and my p term together with the number shit on that side. So over here is my x squared stuff with my x stuff. Nope. How do I get that to happen? I want to subtract 6x, yes? And I could add 27 at the same time. You guys see that? Room. So add 27, subtract 6x. Now that looks like completing the square can do some stuff. And that's a nice one because 6 is divisible by 2. Hey, no fractions. Okay, maybe. Okay. All right. I sense general concern, but I need questions to go off of.
honestly, like, how did you just switch 6 to the other side?
All right, so from here we get, right, subtract 6x, add, well, there's none of this there, add 27. That's all. So we need to get to a point where I don't necessarily have to write that shit down. I know I want this over here, I'm gonna subtract it over. I don't want that over there, so I'm gonna add it over. Yeah. Now, same time I wanna see some work, but what is it that tells you to do that? Honestly, in this problem, it's the instructions saying I have to complete the square. Can anyone tell me if the instructions just said solve, what would I have done differently here? If it just said solve. The only reason I'm doing what I'm doing here is because it said complete the square, and I need room here, right? What if it would have just said solve? What would you have done differently?
Yeah.
Sorry?
Factor it.
Yeah, so I would have left the 27 over here, yes?
Yeah.
And then I would have factored it. And if it's not factorable, I would have probably used quadratic formula, right? The only reason I'm doing this specifically is because it said you have to use completing the square. So I need room, I need to push that guy over there. Now I can do half square, blah, blah, blah. Right? Okay, maybe, yes?
I'm pretty sure that section for number, was that, 15 or what? I think that is factoring.
Is that the factoring one?
Pretty sure.
Oh, that's the factoring one. Beautiful, beautiful. All right, so then you would do, that's why I was asking which section it was in. So now you can just factor this, yeah. Much better. That's what I would do if it just said solve. Okay. All right, I like that. Is that better? So if you had to complete the square, you would move the 27 over, but since this is the section that says factor, now I could just factor it. Get the numbers that do the right things. Okay, I like it. Why did I have to get it equal to 0? Why can't I just leave the 27 over there and then factor this side, right? Why wouldn't that work? If I just leave this 27 over there, can't I factor this? Why is that not good? How many things multiply to be 27? How many numbers multiply to be 27? Give me some. 9 and 3. Give me some more.
1 and 27.
1 and 27. Give me some more. -9, -3. -1, -20. Give me more. I want more. 54 and 1/2. What's 54 times a half?
4.
Freaking 27. What about 270 times 1/10? 270 times 1/10. What is that?
27.
20 freaking 7. So how many things multiply to be 27?
Infinite.
Infinite freaking number. How many things multiply to be 0? Do we know something for sure then?
There
If
has
they
to be a 0.
There must be one of them has to be 0. So that's why if I'm doing by factoring, I want it to equal 0 because then I know one of them has to be 0. Here, it could be almost any. It could be, holy shit, there's an infinite number of things it could be here. But if I make it 0 and I factor it, now one of them must be 0, period. So then I can actually get the 2 answers. Okay, maybe. Maybe. Okay. All right.
Where is that particular problem?
Yeah, it's right there. 2-5. You can't see it. 2-5 number. What was it? Sorry, I was scrolled up for a second.
Number 18.
18. Yeah, right there.
18.
So we can put it back in the right place. There we go. 18.
I've got something else there, I wonder. Oh, no, I guess
Freakadelic.
it isn't. Maybe. Okay, that's x over 3 minus 9 over x.
Yes, that one. Okay.
Okay.
All right. So let's do number 55, and then we're gonna get into some new stuff.
What about 35?
Sorry, 35. Oh, this is the one I thought. Oh yeah, okay. What's quadratic formula again? Can somebody tell me?
Like,
Yes.
X equals.
b squared or something.
That's my notes. I'm getting there. I'm getting there.
X equals negative b,
Plus or minus
square root of
b squared minus 4ac all over 2a.
All right.
Yeah, that.
That's in scruffy stereo. I love it. What part of this tells me if it's going to be real or complex? Where would complex come from?
The radical.
So what part of this tells me if it's going to be real or complex?
B squared minus 4ac.
Do you all agree that if you tell me what A, B, and C are, B squared minus 4AC is just a number, right? Just a number. If that number is positive, what kind of answer am I going to get? Real or complex? Real. If the number is negative, what am I going to get? If the number is 0, how many answers will I get? If the number is 0, what part of this tells me I'm going to get 2 answers normally? What part tells me I'm going to get 2 answers? Plus or minus. If the plus or minus is 0, how many answers do I get? 1. Good. 1. 1 answer. Yeah. But the type depends on what the LA is on, but normally rational, yeah, okay. Are you guys, let me stop for a minute. Do you guys see that? This part is what we call the discriminant. And that's what they say somewhere.
There in
Here.
front of you.
Yeah. Thank you, Mike. So for that problem, it's all about what the hell are A, B, and C, right? Because then you can just throw them in there. So in that problem, you're drunk. In that problem, what's A, B, and C? Number, which one was it, sorry? 35. So number 35, what's A, what's B, what's C?
Minus A, negative 30 is B, and
Yeah. 9A, so it's ax squared plus bx plus c. So A is 9, B is negative 30, C is 25. Throw that stuff in. Just, in fact, don't throw it in the whole damn thing. Does the problem say to solve? It just says use the discriminant to determine blah, blah, blah. So tell me, what number part of this am I looking at? What did we say earlier?
The square root.
What's inside the square root, right? So just do this. For example, if I had 2x squared plus 3x minus 1. A is 2, C is negative 1, B is 3. 9 plus 8, 17. So what kind of answers will I get? Real. I'll get 2 real answers. Because where does this go in the equation? Inside of the square root. Square root of a positive number is real. Square root of 0 is real. Square root of a negative number is complex. Right? So what if instead I had, what do you got, Jeff? 2x squared plus 3x plus 4. Do that real quick. What's b squared minus 4ac? Don't say it. Just try it. Figure out what b squared minus 4ac is. Don't say it. For that problem right there. All right, who's got that? Yeah, so you get 9 minus 32, is that right? Yeah, negative 23. So what kind of answers will I get? Complex. There, done. The problem doesn't say solve. It just says what kind of answers. Does it say how many? Yeah. The only time it's not going to be 2 answers, the only time it won't be 2 answers is if the number I get is 0, because that'll make the plus or minus meaningless. You guys all see that? The reason this comes out with 2 answers normally is because of the plus or minus. But if I'm adding, subtracting 0, I just get 1 answer. Let me show you an example of that real quick, and then we'll do some new stuff. What if I had x squared minus 6x plus 9? B squared would be 36, is that cool? Minus 4 times A times C, and what is 36 minus 36? 0. So I'll get 1 answer. The funny thing is, I want you to not forget something. What's the degree of that problem? What's the degree of this?
It's 2.
So I should get 2 answers, correct? That is the fundamental theorem of algebra that we saw in that video.
You get 1 real and 1 complex.
No, can't. That's impossible. You always get, if you get any complex, it'll be 2
Oh,
because
that's right.
plus or minus. Yeah.
That's right.
Now, real quick, I will get one answer from this, but do you see if I just factor the damn thing? What's the answer? What makes it 0? What makes it 0? What minus 3 is 0? 3. I get one answer, but I get it twice. So there are 2 answers, just they happen to be the same. Okay, maybe. So again, this problem didn't say solve, it just said, hey, before you do anything, just what kind of answers you're gonna get, right? If this is supposed to be telling me how many widgets I have to sell to make the maximum profit, and I'm gonna get a complex answer, my math is wrong. I'm not even gonna waste time figuring out the answers if I know it's gonna come out complex, right? It's hard to sell 7 minus I lemonades. Well, Sal, you gotta sell 7 minus I lemonades to break even. What? Maybe. Okay. Alright. Freak out some kid asking for, I'd like I lemonades, please. Okay. So at this point of the class, you need to feel pretty confident about factoring. You need to understand the basics of complex numbers. And what do I mean by that is, what is I squared? And what is I, right? And you also need to know the various ways to solve a quadratic equation. You need a square, taking the square root, quadratic formula, right? Factoring. You guys with me? You need to have a decent grasp on those things. I think last time we started talking about functions. Make sure, yes.
We never went over 55.
I never did I? The one I kept saying I had to do. This one here, right?
Mm-hmm.
Okay.
55.
So they give us a cost function, they give us a revenue function. Revenue is, of course, the money you bring in. Cost is the money you put out. So how do you figure out profit?
Revenue minus cost.
Revenue minus cost. The money you bring in minus the money you put in out, right? Guess with me. And they tell you that. Recall that profit is revenue minus cost.
Yep.
So can you write a profit function? How would you write a profit function? You would take, what's profit again? Revenue minus cost. What's the revenue? 100x minus 0.5x squared, yes? And you would do what to that?
Subtract that.
Subtract 60x plus 300, right? You guys all with me? So then you have a profit function, correct? One little thing you have to be careful about. What have I done wrong? Here's revenue. I'm going to do something wrong. And here's cost. Okay, I have done something wrong. Yeah. I'm supposed to subtract cost. And negative's got to distribute, right? The 300, for example, might be overhead, which is really low overhead, so maybe this is eliminated stand, but that would be the cost of materials, the cost of renting this place, the cost of utilities, whatever. The fact that it's that low tells me this might be eliminated stand. I don't know, what does it say? No, it says it's a company, so. You guys kind of with me a little bit? Profit is revenue minus cost. They tell me what the revenue is. They tell me what the cost is. I just got to subtract them. Now I got a profit function. Set up a quadratic equation and find 2 values of x that will create a profit. So we got a profit equation. Are there any like terms? Totally. I'm going to distribute the negative, put the like terms together.
Well, you got a 60x and a 100x.
Totally. I love it. Distribute the negative, put your like terms together. And then I want to get a profit of $300. So let me write this. Negative 0.5x squared, 100x minus 60x,
40x.
40x, and then minus 300. Is that cool?
Yeah.
There's my profit function. Where the hell do I shove 300? Do I put it in for x? What's $300? That's the profit that I want. So where does 300 go?
Next bar and
Nope. Definitely not. What's X mean? Production level. So X is always the number of things. Like the number of lemonades I'm going to sell. What's P? Frickin' profit. So if they tell me I want the profit to be 300, where do I put that? Where this? Yeah, P is. 300 equals blah, blah. Now you have a quadratic equation. It doesn't tell you which way to solve it, so you can use quadratic formula if you want to, right? Before you solve a quadratic equation, what are you supposed to make happen? It's supposed to equal, so you're going to have to subtract the 300.
so you do plug it in, or?
No, so here, I did. So profit is 300. And now I'm going to solve that. It says, find values of X. So that's what I don't know. I don't know X. But I do know I want the profit to be 300. If you're a startup company and you put so much money in to get it started, wouldn't you like to be able to predict how much shit you're going to have to make just to break even? Isn't that something you'd like to know? Because if you know where you can break even, then you know, well, we got to make more than that so we can actually, feed ourselves. That would be good, right? So one of my friends, he's no longer with us, but when he was alive, he was a financial analyst. And his job was to keep track of demand and supply and all that kind of stuff and adjust their formulas to know what the price point should be to maximize the number of things, the profit they make. So he could figure out how many things you got to sell and what price point it should be. Oh my God, that would kill me. It's all math, but I'm like, oh, it's business math. But he made a stupid amount of money because that's one of the most important people. What price do we set this at to make the most profit? Right? And that's what he would figure out. He would constantly keep track of it. So, yes?
Where did that weird X go?
I don't know. Oh, from here.
No, but where did it go when you
Oh. 100x minus 60x.
Okay.
Yeah, that's the 40. Okay. Yes?
So you're saying we could put any number for X, but it has to be equal or more than 300?
No, it's got to be equal to 300.
Oh,
So this is not a guess and check. In fact, it's never a guess and check, ever. Right? This is college algebra and trigonometry, which together we call precalculus. So guess and check, never good. And that would suck. I don't want to try to guess and check what x's make this come out to 300. So you just subtract it over and then use quadratic formula. That's what I would do.
oh, okay.
Yeah, I don't want to try to factor this with a negative 0.5 out front.
Yeah.
Okay, maybe. So a lot of, this isn't even a word problem. This really isn't. This isn't. This is not a word problem because they gave me the formulas. I didn't have to create them. I just had to subtract what they gave me. A real word problem, you got to set up the entire formula yourself. That's a word problem. That's why it's difficult. This one, they gave me everything. And they said, now I want you to make it come out to be 300. What X makes it happen? Okay, now I solve it. So one level is getting to the point where you have an equation. And then the next level is, do you know how to solve that equation? What tells me to get this equal to 0? What tells me I need to make this one equal to 0 and then try to factor or quadratic formula? What tells me that?
Negative 0.5.
What about that? Not the negative 0.5, but the fact that it's in front of.
Yeah.
Yeah, if you have a higher power on your x, higher than 1, or different from 1, you're going to have to do some weird. If that wasn't there, wouldn't I just add 300 divided by 40?
Yeah.
Do you guys see that? If that wasn't there, wouldn't I just add 300 divided by 40? Kick ass, because all my x shit would be in one term. All my x shit currently is in 2 terms. Oh, I can't solve for x directly. Which is why we have completed the square, quadratic formula, factoring. We got all that crap. Okay, like it. And again, I know from your perspective right now, and I agree with you, a lot of the word problems you see in mathematics are stupid, and that's why, I can't remember if I put it on you guys, the one about only in mathematics can you buy 60 cantaloupes and nobody wonders what the hell's wrong with you? So many word problems are stupid. Bill forgot how much money you put in the bank. All right, great job, great problem to have, Bill. I know all too well how much money I put in the bank, right? Down to a cent. Are you guys kind of with me? They are stupid. They're dumb, but they're just kind of lower level. If you wanted to model the weather, do you know how crazy the equations are for modeling the weather? Do you understand what I'm saying? How many variables are we able to handle at once right now? 2 at most, right? Y and X. You guys with me? How many variables do you think affect the weather? Stupid amounts, right? And if you buy into it, even like butterflies flapping the wings, butterfly effect. Before it was a movie with Ashton Kutcher, it was actually a long time the idea. I'm sorry, I'm going way off on a tangent. What you are doing right now in this class is just getting used to the processes that we use to do almost any frickin' thing. So yeah, some of the shit is very contrived because we can't handle like completely real world stuff. There's too many variables, so we gotta kind of cut it down until, hey, okay, now this is something we can currently deal with, right? Okay, maybe. Okay. So I think last time let me see if I remember what we did. I talked about the definition of function. I don't know if I wrote down function notation. What was the definition of function again? What makes something a function?
It's got a 1 in
For every
for every
Input.
input.
there's only one output. 11. For example, right? If I input 9 for x, so let's say my input is x equals 9. What do you get for y? What's your output? So really, what's this asking you? I don't even have to do math for this. What do you square to get 9?
Y is 3.
Or,
Minus 3.
everybody with me? Or with Mike?
Maybe.
You guys understand? So how many inputs did I put in? 1. How many outputs did we get?
2.
2. Is that a function?
No.
Hell no. You all know what y equals x squared looks like, right? Can you guys draw it in the air? What's y equals x squared look like? Y equals x squared. Yeah, like that, right? Whee!
Oh.
Parabola. Parabola. You guys all with me? That passes the what? If it was y equals x squared, what does that pass? What test does that pass? Vertical line test. So for every x, it only hits once. For every x value, it only hits once. That's why it works. It's a visualization of the definition of function. What would that look like? Does anyone know? Definitely doesn't look like that. What would that look like? Yeah, it just takes this and turns. So it'll look like this. Does that pass the vertical line test? No. Nope. There's at least one vertical line that goes through more than once. All you need is one. All you need is one. If there's one x value that has more than one output, that's not a function. This has got an infinite number. Holy shit.
That's just a horizontal line.
Yeah, what's that for? Something later. But this is not even a function in the first place. It doesn't even get to take that test.
Yeah.
Yeah. Okay. All right, so a function is defined to be, for every input, there can be only one output. That's a function. So I can do it visually, I can do it computationally. You're going to see both in the homework. Okay, I like it. Yes?
I have a question. So the reason why that one is not a function is because it has 2 outputs, right?
Yeah, I put one number in for x, and I got 2 numbers out for y.
Okay.
Yeah.
So the y squared.
Yeah, exactly.
Okay.
So you can kind of start to understand that as long as you can solve for y with only one answer. So if I try to solve this for y, don't I get out of here. Don't I get, what do I put when I put a square root?
Plus or minus.
Plus or minus. So don't I get y equals plus or minus? So I can't solve for y without having 2 things. So if I could solve for y, meaning if there's only a power of 1 on the y, the minute you get some other power on y, you're screwed. Screwed, I say. Okay. Baby. Okay. We don't work too much with this, but this definitely comes up a decent amount, the idea of function. What we do with functions more often is stuff like this. Like what, Jeff? Let's say I have okay. So if I ask you, what is g of 0? Now, if I used y and I said, what do you get when you plug a 0 in? You're like, what do you mean, which thing? Well, now you know exactly what to use. Where are you going to put 0? For what? There's 2.
G.
Obviously for g.
GX.
Right? So g is 0 means plug a 0 in, and you get 1. Sweet. Nice. So the basics of functions are very straightforward. In fact, they're better than just using y, because I can see the input, I can see the output. Can anyone tell me what is one point that this function would go through if I graphed it? 0, 1. Kick ass. Let me ask you a really weird question. How many answers does this have? Just in general, how many answers does this have?
The equation?
The equation. How many answers does this equation have? Did we just find one? One answer is 0, 1, correct? Yeah. So there's an infinite number. If you've ever wondered why the hell do we graph stuff, number one, that's crazy, because I want to know what the hell. If this models something flying, I want to know what it looks like, so I'm going to graph it. But the most basic reason we graph anything is, if I ask you to give me all the answers to this, give them all to me, how long would you be listing them? Bless you. Forever. So what would I rather do? I'd rather give somebody a picture and go, here, go find whatever one you want. I'm done with you, right? Don't ask for infinite lists. So when I graph something, that is all the solutions, right? This is not a perfect graph, by the way, obviously, but I can, if anybody wants an answer and their answer is further down, I just say, keep going, and leave me alone. Graphing something gives me all the solutions to any equation. It's the quickest way to give somebody all the solutions, because otherwise it'd be an infinite list. Okay. All right. Let's do this. Okay. Let me give you this here, so I can shut up for a little bit and talk a lot.
Chapter 3. Yes, it's a function. Passes the vertical line. So it's a function.
Let's look at the side that says nothing at the top. It says, what does a graph? When does a graph represent a function at the top? Let me show you.
Oh, yeah, that's first side.
Yes, like which is the first side? Who knows? Oh. What did I use? Okay. Oh, that's right. Somebody's.
Oh, I see what you mean. It's the other side. Okay. I was looking at the previous side.
I was looking at the other side too.
Norse. All right, let's take a look at this side. There are equations you can actually do that would spell love. Aw. So there's two of the letters you need. So very quickly, which one of these is a function? Let me get rid of all that stuff. Which one of those is a function?
The second and third.
And why is the first one not?
Because it doesn't pass the vertical.
Yeah,
line.
it doesn't pass the vertical line test. For this x, for example, there are two outputs. There's a vertical line that goes through more than once. So any vertical line relates to exactly one x value. Do you guys agree?
Yes.
That vertical line would specifically be x equals 1, if I'm assuming a 1, 2, 3, 4. That's the line x equals 1. So for that x value, there are two y values. No good. So again, a nice way to think of this, and this is not exactly perfect, but it's pretty close. Could this function model something being thrown in real life? No. If I throw a ball and you tell me that it is 2.5 feet up and 2.5 feet down below the ground, no, I can't do that.
Unless maybe it's a boomerang.
Hmm?
Unless maybe it's a boomerang.
Even if it's a boomerang, how did it get 2.5 feet underground? That's the tunneling version of the boomerang. Boomerang 2.0. This guy's good because he passes. There's no vertical lines that go through more than once. Is this one good?
Yes.
Totally. Anybody know what this is the graph of? Absolute value. Kick ass.
Absolute value.
Yeah, we'll learn that more later. This guy, of course,
No.
Yeah.
he's really cool looking, but he's not a function. Poor little dude. All right, I like it. Hey, Mikey. So last time we talked about these different ways I could give you problems. In this question, it's not, is it a function, but it's what's the domain and range. Can somebody tell me, though, why is this a function? Why is this one a function?
There's only one.
Yeah, is there any x that has more than one output? So what's the shortcut to that? Do I see any x values repeated?
No.
So it's a function. I love it. What is the domain of this function?
The x value.
So tell me, what's the domain? In general, what's domain? Like you said, it's the x values that are used. The x values that have outputs. So what's the domain?
The domain is the x values.
1,
2,
2,
3,
3,
4.
4, 5. Okay. Right? Those are the x values that have outputs. So that's the domain. That's all domain means, is all the x values that are used. And you would write it like this in set notation. 1, 2, 3, 4, 5. Why can't I write it like this? Why would that be wrong?
Because that makes a coordinate.
No. Careful. What notation is this? Do you guys remember? Interval notation. So this would mean every number from 1 to 5. Do you guys remember that?
Yeah.
Is that true? Do I use 2.7? So that can't be the answer. I have to give finite number answers here because I only use 1, 2, 3, 4, 5. I
That's
don't
why
use
you have the curly braces.
curly
versus
braces.
The
Huge
square
alert.
brackets.
Yeah, the brackets would mean from to.
And parenthesis would mean
Yes.
just that.
Since I brought this up, what is the difference between this and this besides the obvious visual difference? What does the bracket mean? Yes.
The points included in the graph.
Yes. And the way I remember that is, doesn't this look like part of an I? The letter I?
Yes.
I for include?
Mhm.
Do you guys remember what you would put in a number line if you did not include something? When you put a open circle?
Oh, yeah.
Doesn't a parenthesis look like part of an open circle?
Yeah.
Okay. So include, exclude.
Yeah.
This would include 1, this would exclude 1. You guys remember that? That's interval notation, yes.
So can we use just parentheses or does it have to be the little squiggly thing?
If you use parentheses, you mean interval.
Okay.
So you would pick up everything. If you want to use finite number of things, you have to use squiggly U's.
Okay.
Yeah. Which is the official name. How you guys doing? We love it, Jeff. Okay. Why is this one a function?
Different outputs.
Good. Be careful the way you say it, because they could all go to 0. Every single one of them could go to 0. But does any input go to more than one output?
No.
Nope. They each go to one thing. Obviously, the domain is what? I forgot to say the
X
range for this
values.
first one. The range is just the y values, right? The domain or 1, 2, 3, 4, and the range is 0, 1, 2, 3. So the domain is all the numbers I use to get outputs, and the range is all the outputs. Okay. So we just put E. What about this guy? Obviously, he's a function because he, or she, I don't know,
Passes the vertical line.
passes the vertical line test, right? What is the domain, though? Let me ask you a quick question. Does -1 have an output?
Yes.
Yes.
It would be negative.
What's
4
the
to
output
1.
for -1? Beautiful, y'all see that?
Yeah.
So if I ask you a question I didn't ask you, but if I said, what is f of -1, you would just say, freaking -4, because I can see that's where they put the point, right? Does 7 have an output? Or let's say 4. Does 4 have an
No.
output? Nope. So is 4 in the domain?
No.
Is -1 in the domain? Totally. What's the lowest number that has an output?
-4.
Yeah, so you can think of a man walking along the x-axis. What's the first time he sees the graph? And -4, yes?
Mm-hmm.
Up to what? And then he sees it forever. Does -1.9387 have an output?
Yes.
Totally. There it is, right? So which notation do I want to use? Do I want to use curly dudes or do I want to use brackets, guys?
Brackets.
Yeah. So from what? What's the, for the domain, what's the lowest number x value?
-4.
-4. And what's the highest x value that has an output?
1.
1. When would I put parentheses? What would have to be here to put parentheses?
An open circle.
Open circle, but that's closed, right? You zoom in, you can see that. What about the range? Somebody else help me out. Come back. There you go. X is our domain, Y is our range. So what's the first time the dude sees it if he's walking on the Y-axis? -5. So the range goes from -5 up to 4. Easy shit, right?
You're still using brackets for that, right?
Still, because there's no open circles there or there. So they're included. I like it. What did I just say? -5 up to 4.
When you say open circles, what are you referring to?
If, do you see how that's closed?
Yeah.
Filled in? If that would have been open, not filled in, that would mean I'm not including that.
Okay.
Yep. I'm not gonna. Like back in the day, real quick. Oh, jeez. Paper. There we go. Back in the day, guys. Back in the day. If I wanted to say x greater than -4, how would you graph that?
It's above the thing there.
Thank you. How would you graph x greater than -4? You could do this.
Well, you have, well, where.
What would you put in the -4? Open circle, right? Or you used to. We're not going to do that anymore, but I'll show you. So you put an open circle and then you would shade the direction this is pointing. So we don't do that shit anymore. Now we're better. Does anyone know what we put on the -4 now? Do I include -4?
You use a
Nope.
parenthesis.
So I use parentheses. And again, it's just half of an open circle there, right? And I always think the way I remember this is it's sort of like Dragon Ball, where it's right? So it looks like shwa. So you always open this in the way you're gonna shape. Okay. Again, it's not a prerequisite to watch any Dragon Ball. How would I write this in interval notations? Anyone remember? What's the lowest it could be?
-4.
Do we include it?
No.
Nope. Up to what?
Infinity.
Kick ass, make an infinity, Jeff. There you go. Lazy 8. Okay. Alright, is that all coming back? Sort of. Okay.
To infinity and beyond.
Thanks, Mike. I love it.
What about? Oh, wait, you're getting
Alright, what immediately strikes you about this one?
open circle.
Open circle. Oh shit. So the domain, what else strikes you on the ends?
Infinity.
Alright, so what's the domain? What's the lowest input?
Infinity.
What kind of infinity?
Negative.
Negative. So the domain here would be negative infinity up to, what, it go with negative infinity to infinity?
Yeah.
Nope.
No?
Where do I stop? What's not included?
-3?
Negative 3 is not included, correct? So don't I have to stop at negative 3? You guys with me? I can't say negative infinity to infinity because I'm lying.
Oh, wait, I'm lost.
Do you agree with me that I can't use every x value? Or let me say this, not every x value has an output. Do you agree with me? Is there an x value that does not have an output? What x value does not have an output? Negative 3 does not have an output. Do you see that? Is everybody with me? It's not shaded, so it doesn't exist there.
Okay.
So I can't say negative infinity to infinity. That would be lying. Where do I have to stop? Negative infinity, I have to stop where?
Negative.
I've got to stop at negative 3. Do I include negative 3?
No.
That's the whole problem, right? So you put a parenthesis in that dude. I don't want to include him. I don't put an I, I put a bracket. I'm sorry, a soft parenthesis. But doesn't it go further?
Yes.
Does anyone remember the symbol we can put in there that means or, and then I can pick up again from negative 3
Oh,
up to
infinity.
infinity. So I always just think of this as saying skip. That just says skip negative 3. Does that look familiar to anybody?
Mhm.
A little bit? Some of you guys are like, dude, that's like 6 years ago. I
It's
understand.
like union versus intersect.
Beautiful. So that's a union. That means either set works.
Means
Or.
or intersect means and.
What about the range?
Range.
What's the lowest output I can get?
Infinity. Negative
Infinity.
infinity.
Negative infinity. Does it also have somewhere it's got to stop?
Negative
Good. Negative 2.
And then
Pick back up.
-2
Negative 2 to
infinity.
infinity.
Infinity and beyond.
Okay. Stop for a minute. All right. So let's look at this here. Any questions on those? So I could give you any of these representations and ask you for the domain and range. What do you tell yourself? Domain is all the x's that have outputs. Range is all the outputs. Right? Yeah.
Does it matter where the port is?
Yes, it's in between the two sets.
Like you put it next to the.
Oh, so again, there's just no room here, but if I was going to write this out fully, let me do this. If I was going to really write the domain out fully for this, it would be from negative infinity to negative 3, or negative 3 to infinity. Right? In between the two sets. Yeah. So this is just me running up against the edge of the paper and starting over. Okay. What does your gut instinct tell you for this? Given the picture here. And do I even tell you what the function is? Do I even give you the function? Do I tell you what the function is anywhere? Is it x squared plus 3? Is it? Do I tell you what the function is? No, I don't. Right? Yes, because I'm a jackass. No. I give you something better. I give you something way better. I give you all the frickin' answers. Yeah, give me all the answers. Don't give me the shit. Give me the answers. Can anyone tell me what f of negative 1 must be? Why must it be 2?
It's the input.
Because if you put something in and you got an answer out, isn't that where you would put the point? So wherever the hell they put the point must be what the freaking answer was. So for an input of negative 1, the output was 2. Done. That kicks a lot of ass. I don't have anything to do. I just got to look and see what the number is. So what's part B here? Sorry, not negative 2 plus 1. What's f of negative 2?
Negative 2.
Negative 2. And what's f of 5?
0.
Good, 0. Because they put the point at 5, 0.
Yeah.
That's nice. No work to do because somebody else already did all the work. All right, real quick, don't say anything. Figure out the domain and range. Don't say anything. Alright guys, what's the domain?
Minus
Negative
2 plus, minus 1, 1 and 5.
Oh, no, okay, be careful.
This is,
Does negative 1.7 have an output?
No.
Total. If it was just dots with no lines connecting, then it would be a finite collection of domain elements, right?
huh?
You guys with me? They're connected, which means this point works, this point works, this point works, this point works, this point works. So what notation am I going to use?
Well,
Yeah, interval notation, so bracket stuff. Why am I going to use a bracket? Closed circle, I love it. So from negative 2 up to what?
5.
5. So that's the domain. Range. Now look at the y-axis. From negative 3 up to
2.
2. Alright, eat that shit up. If I give you that kind of problem, you should just go, oh, thank the gods. Alright, bam, bam, right? Okay. Yes? I'm sorry? Oh. I don't like overhead, so I'm sorry. Just tell me if I'm not on it, alright? Yes? No, you don't. I just am so used to doing that. This was domain, you don't need that. This was region. I want you to see how question F is kind of the reverse of these. These were, if x is negative 1, what's y? That's another way to say this. If the input's negative 1, what's the output? This is, what inputs make the output negative 3? That's the question. Do you guys see that? What would I put in to get the output to be negative 3? 1. To make the output negative 3, I have to put 1 in. Where is this function increasing?
negative 2 to negative 1, and from 1
Yeah, good. So when I say where is something happening, that's x stuff. So isn't it increasing from negative 2 up to negative 1? Not what are the max and min values. Where is it increasing? From negative 2 to negative 1. That's one place it's increasing. Where else is it increasing?
From 1 to 5.
And here's something a little weird. Is it increasing right at negative 2?
No.
I don't know. Doesn't even exist. So I'm going to do this. You almost never include the endpoints. Negative 2 to negative 1, it's increasing. Where else is it increasing?
From
1 to 5.
1 to 5. Kick ass. Not a huge okay. What about decreasing?
Negative 1.
Negative 1.
To 1.
1. So from negative 1 to 1. Look here, notice this. See this?
It's a little off the screen.
Sorry. Come here, you. See this? Notice this? Negative 1 to 1, negative 1 to 1. Kind of makes sense. If it's not increasing, it must be decreasing. Maybe. Let me just get your take on this. I haven't even talked about this. What is the local max? What's the local maximum?
2.
Totally. 2. 2 is the local maximum. It's kind of like, where's the hill? Where's the top of the hill? Where's the local minimum?
1.
Negative 3.
Well, negative.
So what is the local max? Not, I might have just said where, but what is the local max? Not where. So if I said where's the local max, you would say add x equal negative 1. What is it? 2.
Okay.
So what is the local max? 2. What is the local min? Negative 3. Yeah.
If there were 3 areas of it increasing, would you put 3 points?
With 2 u's, yep. Yep. If there were 3 intervals where it was increasing, you would need 3 sets with 2 u's in between. Yep. Okay. All right, guys. Fun never ends. All right. Try this first problem out on your own. You can work with people near you if you want to. Oh, good. shouldn't be too crazy. Is it a function?
Yes.
Why?
It only has one output for each input, and it passes the vertical line test.
Kick ass. So you can say either of those, you can say both of those. Vertical line test is a visualization of the definition. So you can either say for every input there's only one output, you could say passes the vertical line test, you could say passes the volt. Okay. Domain, in -8 up to 4. And there's no open circles or anything, so there's nothing to throw out. Range,
-7 to 2.
-7 to 2, gas, lowest output, highest output. Alright, somebody else tell me what's f of -6?
2.
That's where they put the point. Where is it increasing?
Between -8 and.
Yeah, from -8 to -6,
And
or,
1 to 4.
oops, from 1 to 4, I love it. What about decreasing?
-6 to 1.
Yeah, -6 to 1.
Why are you using parentheses without the brackets?
So tell me, right at -6, right at -6, is it going up? Is it going down?
Both.
Or neither, right?
Either.
It's sort of like when I throw the pen in the air, right at the top, is it going up or is it going down? Neither. It's just there for a moment, right? Just kind of thinking about life and wondering if I'll catch it. So that's why I don't include these. Because it's not doing either at that point. It's not going up or down. It's turning, right? Okay. And again, on a quiz or something, if you put bracket, I would just cross through it. I probably wouldn't take points off, but we'll see how I'm feeling.
So what you're saying is no one get you in a bad mood when you're grading tests.
Oh man, that would make it sound like I'm not professional, but I am human. No. I'm trying to remember. It depends on if you do it a lot, then I might take some points off. Yeah. Local max value.
2.
Not where is the max value.
It is 2.
What is the max value? It's
2 located at x equals -6.
Kick ass. Where does it occur? X equals -6. Local min value. -7. Where does it occur?
At x equals 1.
X equals 1. Where? X. What? Y.
Basically just-
Vertical line
just
test,
give
sorry.
this one based on-
Vertical line test, yeah. What time we got?
These ones?
I'll tell you this.
I don't think that's
I'll
that. Okay.
do one more thing here really quickly, and then we'll finish this up next time. If I Let me do a couple examples of this, and then we'll pick it up next time. And don't forget, if you came in after I put that up there, the quiz is tomorrow. Yay! By the way, that's going to be pretty short, to the point, kind of basic. I like my quizzes to be nuts and bolts, straightforward, to the point. That doesn't mean my tests are evil and all that kind of stuff, but still. Can somebody tell me, if I had this function, is there a value I cannot use as an input? Yeah, what's wrong if I try to use 1 as an input? What do I get if I try to use 1 as an input?
Well, the denominator would be
1 over
0.
0.
And it can't be 0.
What is that called, by the way?
It's right here and right here.
Undefined. Why is it called undefined? Yeah, so it's real quick. What is 6 divided by 2?
Okay. But is it increasing?
Holy shit. Because 3 is the number defined in such a way that when I multiply it by 2, I get 6. Let me say that again. 3 is the number defined in such a way that when I multiply by 2, I get 6. So what is 1 divided by 0? It would have to be the number defined in such a way that when I multiply by 0, I get 1. Is there any number defined to do that?
No.
Undefined. That's why we call it undefined. What else? Does anybody else have a teacher call this something different? Think about slope. Rise 1, run none. Rise 1, run none. Rise infinite slope. So sometimes you'll see some teachers call this infinite. Undefined is a more kind of like generally accepted thing to call this. So what would the domain of this be? Is there any other number that gives me a problem? For every other number, don't I just get a regular old fraction out? 1 is the only one that freaks me out. So what's the domain? What's the lowest thing I could put in for x? The lowest number that I can put in. Could I put -7? That would be -1/8, correct? That's perfect. Could I put -7 billion? So what's the lowest? Negative infinity. Can I go forever up? Where do I have to stop? 1. There's a problem at 1, correct? And then I can pick back up at 1 and go to infinity. So it wants to be negative infinity to infinity, but I gotta skip 1 because there's an issue at 1. It freaks out at 1. All right. So before I let you out, what if I had this instead? What if I had h of x is 1 over x squared minus 6x? What, Jeff? I don't know, dude. Plus 16. There. How do you figure out what values you have to throw out? Why is this one harder? So what do I have to do first to figure out what values to throw out? Factor this because I want to set it equal to 0. I want to see what makes the bottom 0.
-8 and 2.
Yeah, well, it should be a -8 and 2, but make that -16, Jeff. Come on. X minus 8. X plus 2, so then what would I throw out? X can't be 8, X can't be -2. So the domain, that's another way to write the domain quicker. The domain is everything except 8 and -2. Alright, that's plenty. So tomorrow we'll have that quiz first thing. Do some more chapter 3. Just reminding you guys, the next test, when's the first test?
13th.
Yeah, it's a week from tomorrow. If I'm not mistaken. Yes, a week from tomorrow. Yay!